Welcome to OOTO TV, the out-of-the-office investigation from the past into the future. This time we're discussing AI, LLM, and GPT, AI app, and website code development.
Hello, everyone. We're going to get into what's really going on with artificial intelligence, large language models, and those generative pre-trained transformers.
Yeah, and not just what they are, but how they actually work, under the hood. And maybe more importantly, how they're really shaking things up and how apps and websites get built.
It's a fundamental shift, absolutely. We'll kick things off by grounding ourselves in these core ideas, AI, LLMs, GPT, what makes them tick.
Right. Then we'll look at how they're transforming software development itself, the practical impact.
And a big part of that is prompt engineering. Knowing how to talk to these AIs is, well, it's becoming a crucial skill. We need to cover that.
Definitely. And we'll look at some specific open AI models, the ones geared towards coding, so you know which tool fits where.
And finally, we can't ignore the quality side, QA, ethics, the new skills developers need. It's all part of the picture.
Okay, let's start with the basics then. AI, LLMs, GPT. When we talk about AI-assisted software development, what are we really talking about?
Well, it's more than just, fancy autocomplete. It's using AI and machine learning to seriously boost the whole development process, making things faster, smoother.
Augmenting the developer, kind of.
Exactly. Augmenting. And the core engine behind that usually is these advanced large language models, LLMs, and machine learning, specifically for tasks like generating code.
So large language models, LLMs, we hear that term constantly. What makes them large and, well, powerful?
It really comes down to two things. The data they're trained on and their internal complexity, their parameters. An LLM is a type of foundation model.
Foundation model.
Yeah, meaning it's pre-trained on just absolutely massive amounts of data. We're talking books, articles, websites, conversations, and importantly for us, huge amounts of code from places like GitHub.
And this data is huge. Like, how much are we talking?
Astronomical amounts. Think petabytes of text. For instance, GPT-3, one of the well-known ones, was trained on about 45 terabytes of text data.
Wow. 45 terabytes, that's hard to even visualize.
It is. And then you have the parameters. These are like the internal knobs the model can tune as it learns. More parameters generally mean it can handle more complexity.
So more data, more parameters.
Right. GPT-3 used something like 175 billion parameters. It's this combination that lets it learn the patterns, the structure, the nuances of both human language and code.
And the goal is for it to generate stuff that makes sense, like coherent text or code that actually works.
Exactly. To mimic human language and, crucially for developers, to produce code snippets that are syntactically correct and actually relevant to the task.
Okay, so that's the scale. But how do they do it? What are the mechanics?
It boils down to three main parts: data, architecture, and training. We've covered the data. It's the fuel, the knowledge base.
Right, the massive amounts of text and code.
Then there's the architecture. For models like GPT, the key is the transformer architecture. It's a type of neural network designed specifically for sequences, like sentences or lines of code.
And what's special about the transformer?
It's attention mechanism. It allows the model to look at an entire sequence and weigh the importance of different words or code elements when predicting the next one. It understands context across the whole input, not just word by word.
Ah, okay, so it sees the bigger picture. That sounds crucial for coding.
Absolutely. It helps it understand relationships, dependencies, all the stuff that makes code work. And the third part is training.
How does that work?
It's essentially learning to predict the next token. A token could be a word, part of a word, or a piece of code. It starts by guessing, compares its guess to the actual next token in the training data, sees the difference.
The error.
Right. And then it adjusts its internal parameters, those billions of knobs, just a tiny bit to reduce that error next time. Repeat that billions, trillions of times.
And it gets really good at predicting the next piece of code or text.
Precisely. It learns the statistical patterns of language and code so well that it can generate novel, coherent sequences.
And I heard about fine-tuning, too.
Yeah, that's a key step. After the massive pre-training on general data, you can take that model and train it either on a smaller, more specific data set, like just focusing on Python code or medical texts.
To make it even better at that specific task.
Exactly. It refines its knowledge for specialized applications.
Got it. And GPT itself, generative pre-trained transformer that just refers to models using this approach, like GPT-4.
Correct. Models like GPT-4 and the newer GPT-4o are the powerhouses behind tools like ChatGPT and many code generation tools.
Which brings us back to development. These LLMs are generating code, reviewing code. They're like collaborators, right?
Very much so.
Mhm.
Intelligent collaborators offering suggestions, automating parts of the process, providing insights. It's a huge boost.
Okay, let's be really clear here then. It feels like we need to state this emphatically. AI, LLM, and GPT, AI app and website code development, has profoundly changed how coding workflows and applications and websites are built. It's not just hype.
No, it's absolutely real. The transformation is significant. Think about automating code generation. You give the AI requirements, and it can spit out decent code snippets, sometimes even whole functions or basic structures.
Which saves a ton of time on the repetitive stuff, I
A
imagine.
massive amount. It lets developers jumpstart projects and focus on the harder, more creative problems instead of boilerplate code. The speed increase can be exponential. Some people think a huge chunk of code in the future will be AI generated first.
And it's not just starting from scratch, right? What about things like auto-completion?
It's like autocomplete on steroids. These LLMs can anticipate not just the next word or variable, but entire lines or blocks of code based on the context. It really boosts efficiency.
That sounds amazing. And you know what strikes me? It feels like this is making coding, well, easier to get into for people.
Oh, definitely. It's significantly lowering the barrier to entry. Beginners, or even people who don't traditionally code, can use these tools to generate code without needing to know every single detail of the syntax up front.
It's opening it up. Actually, people are starting to call this whole approach vibe coding. You sort of describe the vibe, the goal, and the AI helps you get there. It sounds fun, low cost, easy, really powerful.
That's a great way to put it. Vibe coding. It captures that interactive, less intimidating feel. And these tools are often integrated right into the coding environment, the IDE.
Like GitHub Copilot or Amazon Q.
Exactly. They sit right there with you, like a digital AI pair programmer, constantly offering suggestions.
And they work across different languages, Python, Java, JavaScript.
Yep, they're largely language agnostic. They learn the patterns of many languages. Some can even help translate code from one language to another, which is incredible.
That's huge for dealing with old code or different platforms. What about documentation? Nobody likes writing documentation.
Huh? True. And generative AI can actually help there too. It can analyze a function or class and automatically generate comments explaining what it does, its parameters, what it returns, improves clarity, and makes code easier to maintain.
So the whole development environment is becoming more interactive, dynamic.
That's exactly it. It's evolving. It's less static typing, more of a conversation with your tools.
You're listening to OOTOTV with research by author Paul Bulow.
Welcome back. So we've established these AI tools are powerful, but getting the best out of them requires skill. This brings us to prompt engineering.
Right. You said earlier, AI can do remarkable things if you have the right prompts. So prompt engineering is basically the art and science of crafting those effective prompts.
Precisely. It's how you guide the AI model towards the specific code or output you actually want. Better prompts lead to much better results.
Because they aren't mind readers. You can't just vaguely ask for something and expect perfection. The way you phrase the request changes everything.
Absolutely. And the great news here is that anyone can learn to build prompts. You can instruct these tools to quickly write code that can often be deployed, maybe with some checks, pretty fast using this AI, LLM, and GPT approach. It's an accessible skill.
Okay, so what are some key strategies for developers when writing prompts?
Well, there are a few useful patterns. One I really like is the role prompt. You tell the AI to act as a specific persona,
Like what?
like act as a senior database administrator, or you are a cybersecurity expert reviewing this code for vulnerabilities.
Yeah.
Setting that role helps focus the AI's response, its vocabulary, its priorities. You get much more relevant output.
That makes sense. It gives it context. What else?
There's the straightforward Q&A strategy prompt for getting direct answers. Then the pros and cons prompt, great for exploring trade-offs, maybe between different algorithms or design choices.
Okay.
And the stepwise chain of thought prompt. This is really good for complex problems. You basically ask the AI to break down its reasoning step by step, which often leads to more logical and robust solutions.
Guiding its thinking process. Interesting. Now, what about common mistakes? Where do people go wrong with prompts?
Oh, number one is definitely being too vague. Just typing, write a script or explain this code. The AI has no idea what script or what aspect of the code you care about.
Right, you get generic, unhelpful stuff back.
Exactly. The fix is be specific. Treat it like giving instructions to a junior developer. What language? What should it do? Any libraries to use? What's the input, the output format? Give it details.
So instead of write a Python script, it's write a Python script using the requests library to fetch data from this specific API endpoint, parse the JSON response, and extract the userid field.
Perfect. That gives the AI a clear target.
Hmm.
Another mistake is trying to cram too many different tasks into one prompt.
Like asking it to write code, summarize it, and translate it all at once.
Yeah, that often confuses the AI and the output gets messy. AI works best when it focuses on one thing at a time.
So the fix is to break it down.
Yep. Use prompt chaining. First, ask for the code. Get that right. Then, in a new prompt, ask it to summarize the code you just got. Then, ask it to translate the summary, one step at a time.
Okay, sequential prompts. Makes sense. What's mistake number 3?
Assuming the first try should be perfect. Especially with code, you often need to iterate. The first output might be okay, but not quite right.
So don't just give up if the first result isn't amazing.
Absolutely not. Treat it like a conversation. Look at the output, figure out what's wrong or missing, and then give the AI follow-up instructions. Make this function more efficient, or add error handling for this case, or explain this part of the code.
Refine it step by step, like you would with a human collaborator.
Exactly. And the last big mistake, number 4, is forgetting the AI has limitations. It generates text based on patterns it learned, not real understanding or confirmed facts.
The hallucinations problem. It can just make stuff up, right? Or produce code that looks plausible but is subtly wrong or insecure.
It certainly can. That's why you must use it as a collaborator, not an infallible oracle. It's fantastic for drafting, brainstorming, getting you started. But you, the human developer, need to apply critical thinking, check the facts, test the code rigorously, especially for anything important.
Verify, verify, verify. Got it. So AI is a powerful assistant, but needs careful guidance and review.
That's the key takeaway. Master the prompts, iterate, and always apply your own judgment.
Okay, let's shift gears slightly and look at the specific tools. Within the OpenAI world, how do developers choose the right model for coding tasks?
That's a really important decision, yeah, because different models have different strengths, speeds, and costs. It affects everything from code generation to debugging.
And there's been an evolution, hasn't there, from the early days to now?
Definitely. It started with Codex, which was based on GPT-3, but specifically fine-tuned on code.
Yeah.
Then came GPT-4, a huge leap in general reasoning and coding ability. And now we have GPT-4o, the latest Omni model.
Let's break those down. What was Codex like?
Codex was trained heavily on public code, from GitHub, Stack Overflow, etc. It was pretty good at translating natural language descriptions into simple code, especially Python. It powered the first version of GitHub Copilot.
But it had limitations.
Oh yeah. Its context window, how much code it could look at once, was small, maybe 4,000 tokens. Its reasoning wasn't as deep, and it made more errors. For serious complex development today, it's basically obsolete.
Okay, so then came GPT-4. What was the big deal there?
GPT-4 was a significant improvement. Much better at understanding complex instructions, handling different programming styles like object-oriented versus functional, and generating more robust, often type-safe code.
And its context window was?
Much bigger, up to 128,000 tokens in some versions. That means it can understand relationships across multiple files, grasp the architecture of a larger project, summarize big code bases, maintain consistency. It's much more capable for real-world projects.
So good for writing tests, maybe, or dealing with complex APIs.
Exactly. Writing tricky test cases, integrating external services with proper error handling, debugging really weird runtime issues where you need that deep context. That's where GPT-4 shines.
What's the downside?
Speed and cost.
No.
Being so powerful, it's computationally heavier. Responses can be slower, and using it via API costs more per token compared to older or smaller models.
Right. Which brings us to the latest one, GPT-4o, the Omni model. What's its story?
GPT-4o is designed to be the best of both worlds. Kind of. It aims to match GPT-4's high accuracy and coding capability, but be much faster and cheaper.
Faster? How much faster?
Significantly. For most typical coding prompts, response times are down to maybe 2-3 seconds compared to 10-20 seconds or more for complex GPT-4 tasks. That makes it feel much more interactive.
And it has multimodal capabilities. What does that mean?
That's the other huge thing. It can natively understand and generate not just text, but also audio, images, and even video.
Whoa. How does that apply to coding?
Imagine feeding it a picture of a UI design, like a sketch or a mock-up, and having it generate the front-end code, HTML, CSS, JavaScript for it, or describing a function out loud and having it write the code. It opens up totally new workflows.
That sounds potentially game-changing.
It really could be. Plus, it's more cost-effective than GPT-4, making it practical for building custom tools or integrating into IDEs more broadly. For most development tasks starting now, in 2025, GPT-4o is probably the recommended default. Best balance of speed, smarts, and cost.
And the benchmarks back this up.
Yeah, tests like Human Eval Plus show GPT-4o's code generation accuracy is right up there with GPT-4, around 82%, while Codex was way down below 30%. And in latency, GPT-4o is clearly the fastest.
Okay, so the tools are getting incredibly powerful and accessible.
They really are. And what this all means, fundamentally, is that AI, LLM, and GPT, AI app, and website code development is genuinely within reach of pretty much everyone, everywhere. Whether you're on a phone or a desktop, these capabilities are becoming widely available.
That's incredibly democratizing.
It is. But, and this is a crucial, but it doesn't eliminate the need for good software development practices. You still absolutely need proper planning, clear outlines, business understanding, rigorous quality assurance testing, revisions. All the traditional steps are still vital for deploying reliable software.
So AI helps you build faster, maybe easier, but it doesn't replace the engineering discipline required.
Exactly. It's a powerful tool in the toolbox, not a shortcut that bypasses quality or planning.
Right, okay. We've covered a lot of ground. Let's maybe pull things together a bit. Recap the journey.
Sounds good. So we started with the foundations.
Yeah.
LLMs as these huge data-trained, transformer-based models.
Yeah.
The engines driving this AI-assisted development.
Yeah, and we saw their massive impact. Automating code, speeding things up, making coding way more accessible, that whole vibe coding idea, and slotting right into the tools developers already use.
Then we really dug into prompt engineering, the absolute necessity of being specific, asking the right way, maybe assigning roles, breaking tasks down, and iterating. That's how you unlock the real power.
Can't just wing it with the prompts.
Definitely not for complex tasks. And we looked at the OpenAI model evolution from Codex starting things off to the powerful GPT-4 and now the fast multimodal GPT-4o, each suited for different needs.
So thinking about the bigger picture, what are the key themes we keep coming back to?
Well, number one for me is that this is about collaboration. Human-AI collaboration. The AI assists, it augments, but human oversight, critical thinking, creativity that's still essential. Developers guide the AI.
It's not about replacement, it's about partnership.
Exactly, which leads to the evolving skill set needed. It's not just about writing code anymore. It's also about prompt engineering, understanding how to evaluate AI output, maybe even thinking more about the data involved.
Adapting to the new tools, and alongside that, quality assurance becomes even more critical, doesn't it?
Absolutely, because AI can generate buggy or insecure code. So rigorous code reviews, automated testing using tools like static analyzers, these practices are non-negotiable for any code, whether a human or an AI wrote the first draft. QA is vital.
So it slots into and reinforces the traditional development lifecycle, including QA and revisions.
Right, it doesn't replace those phases. It might change how they're done, but they're still fundamental.
Okay, that makes a lot of sense. So as we wrap up, maybe a final thought for our listeners to mull over.
Well, as AI keeps evolving at this incredible pace, really changing the definition of what a developer does, the question becomes, how will you keep adapting, learning, and innovating in this new era of intelligent code creation?
Yeah, it feels like the journey of AI-assisted development is really just hitting its stride, heading towards this exponential future. What amazing new things will this partnership between human minds and artificial intelligence unlock next? It's exciting to think about.